In previous lessons, we practiced using Python console for calculations. Basically, we use the console as calculator in a sense. We also covered the concept of types in Python. Now, today's lesson, I'd like to talk about the concept of variables, which are the building block for software or program. A variable is a name for storing or referencing certain type of data. In Python, in fact, a variable is more like a reference for certain type of data. There are quite a few grammar rules related to using variables in Python, such as when you declare a variable, you cannot associate that with a type. This is very different from other mainstream programming languages such as C++ or Java, where you typically declare a variable with a type. Now let's work on some concrete examples to help us understand how to use variables in Python and the naming conventions and rules about the variables and the caveats of using them. As usual, we start Python console in PyCharm. We see this Python console prompts with this blinking cursor, so we know the Python console is active. Now we can do something with this console. We can do this simple calculation. This is what we learned before. Now what about declaring variables in console? A variable is a name, a string name. So let's give a variable name A, and we want it store a value. How about 3? So this is the way we create a variable in Python. Let's enter. Now A's value is 3. Let's declare another variable. How about a B? And let it equals to 4. Enter. From this point on, B comes into being. It starts its life in Python. Python knows the existence of B now. So B is 4. What we can make use of these variables? We can do this, A plus B, because A is 3 and B is 4 now. So A plus B, it must be equal to, yes, 3 plus 4, 7. A variable's name does not have to be just a letter or this short. It can be any string started with a letter. For example, word, X, Y, Z. Okay, and we want to use this reference string. We know a string is just a sequence of characters. And hit enter. Now word X, Y, Z begins its existence in Python. From this point on, Python knows what word X, Y, Z references. So it's a string. It's the school name, Baishan. There are certain rules about creating variables in Python language. For example, you cannot use some special character, for example, this $sign for a variable name. Okay, if you do that, it says some invalid syntax. But you are allowed to create variable starting with a letter followed by some numbers. For example, A, 1, 2, 3, and we'll let it equal to 1, 2, 3. A, 1, 2, 3. Yeah, it is 1, 2, 3 now. The rationale of creating or naming a variable is make the variable's name as meaningful as possible. You don't want to have some variable in your program that very confusing or misleading. Of course, right now we are practicing very simple variables. We don't need to worry about that very much. Another thing is some special characters are not allowed in the variable names is for obvious reasons, because those special characters, for example, the slash or double slash, are used for division or floor division. Also, variables in Python is case sensitive. A lowercase and uppercase variable are different variables in the language. Now we know A is 3 now. What about uppercase A if we let it equal to 2 or assign 2 to A? Now uppercase A is 2. So the lowercase a is not the same as uppercase A. There are two different variables. Also, noticing when I declare the variable A, B, or word X, Y, Z, or uppercase A, or A, 1, 2, 3, I don't have the types associated with them. Although the type for those variables actually are known to Python at the time it is created. If you're interested, you can check A, because we assigned integer value to A, so the type of A is integer. And if we want to check the type of word XYZ, because we assigned string to it, the type of it is a string. So even Python does not explicitly ask you to declare a variable with a type, but these variables do have types at the time when they are declared or assigned. Now let's move on. What happens if I assign a different number to A, a floating number to A? Well, it is allowed, but once a different type, a numerical type assigned to the same variable which is declared before, the type might change. So if you check type of A at this time, it is a float now. I restarted Python console. Now it's cleaner. And let's work on another example. Let's assign some value to variable 1. How about 10? var1 is a variable. The name is legit, starts with a letter. The number follows the letter, so it's a legit name. var1. So var hasn't been assigned. So that's why you say this name error. Var is not defined. That's okay, because what we defined actually is var1. So var1 is 10. Good. And let's assign another number. How about 20 to var2? Okay. var1, var2, 10, 20. That's what we expected. var1 now references number 10, and var2 references number 20. Now what about we do this? We let var1 equal to var2, or assign var2 to var1. What shall be the values for var1 and 2? They're the same now. They should be of the same value. Let's check it. Enter var1, comma, var2. var1 now should be 20 as well, because we assigned var2, which is 20, to var1. Okay, 2020. So they are the same. That's what it appeared to be. Now, what if we change var2 to 0? Nothing wrong with that. We just want to make var2 0. Let's check var2 0. Very good. Now, what about the var1 at this point? They were equal, but we changed var2 to 0. Will var1 changes as well? Let's check var1. Wow, it's still 20. But why? So the change of value of var2 did not change the value of var1, which was the same as var2. So there's something going on here. I'll have to draw on a whiteboard to explain this to you. This is one of the caveats you encounter in Python programming and sometimes in other programming languages. When we assign 10 to var1 and 20 to var2, what actually happens is var1 points to a value 10 somewhere in the computer memory, and var2 points to a value 20 somewhere in the memory. When we make these two variables equal, or we let var1 equal to var2 or assign var2 to var1, what happens is var1 points to number 20, which var2 points to, and this is disconnected. And when we assign 0 to var2, this is the trick. Somewhere in the memory, there's 0 created, and var2 points to the new 0. So var1 still references number 20. All right, let's go back to our Python console. This is where we left. The story doesn't just end here. It's more complicated. Let's say we change var1 to a list, 1, 2, 3. Remember, a list is a collection with ordered items in it, defined by using these square brackets. So var1 equals to list 1, 2, 3, enter. var2, the same, assign the same list 1, 2, 3 to var2. Enter var1, var2. Also, by reassigning list to var1 and var2, the underlying types of them have changed. Let's do one thing. A var2 pop 0. Pop basically removes the first item from a list. So we removed the first item from var2. The first item in var2 is 1. We removed it, so it shall be 2 and 3. What about var1? Is it the same list as before, 1, 2, 3, or it is 2 and 3? Well, hit enter. So it is still the same as before, 1 to 3. Removing an item from var2 does not change var1 at all. This is actually not that hard to understand. Even though the two lists appear to be the same, but in memory they created at different places. In other words, var1 has its own copy of a list 1 to 3, and var2 has its own copy of the list 1 to 3. So changing the list of var2's copy does not change var1's copy. Now this gets more interesting. We do similar things as before. We let var2 equal to var1. var1, var2. What this should be, because var1 is 1 to 3, and we let var2 equal to var1. So var2's value must be the same as var1, which is 1 to 3. So both of them are 1 to 3. Now let's do this. Still var2 pop 0. That removes the first item in var2. And let's check var2's content. The first item in var2 was 1. We removed it. So what's left must be 2 and 3. Correct. So we modified the value of var2. Now what about var1? In the previous example, when both var1 and var2 point to numbers, changing one does not change the other, even though they point to the reference to the same value. But now, the types are different. var1 and var2 reference a list. So we changed var2, we removed one item from it. It's 2, 3 now. What should be var1? Does removing the item from var2 change var1? Let's check. Well, you see the behavior is different when we change the list. var2, var1 also changed. That actually implies var1 and var2 referenced the same underlying data. Now let me draw on the whiteboard to explain this. When we reassign var1 to a list, 1, 2, 3, it got its own copy of that list, 1 to 3. var2, when we reassign var2 to list 1 to 3, actually it got a different copy of list 1 to 3. It's two lists just with the same contents. When we call var2 pop 0, which removes the first item, it only changes var2's copy of the list. So it has only 2 and 3 left. When we let var2 equal to var1, essentially we let var2 points to var1's copy of the list. So this is disconnected. So far the story is the same as the previous one. Next, when we call var2 pop 0, because var2 references this, we pop 0, meaning remove the first item out of this. So essentially, we modified the list pointed by var1 as well. This is why after we use var2 to remove the list first item, var1's list also changed because this is the same list pointed by two variables. This is a different behavior for list from integer type.